Okay, guys, so let's start the session. And in today's class, we are going to discuss the next concept called as NumPy, which is related to Python for data science, right? So yeah, so in the last class, we have completed the core Python. So in the main core Python, we have seen with main part is with respect to the loops, and next one is functions. And in the last class, we have discussed about modules. So modules means where multiple functions, a group of functions or variables or set is going to have, and we are going to work on the directly modules by using that functions. Okay, within the modules, we are having a group of functions, and once we import that one, once we import from that whatever the function is there related to inside that particular module, we are going to use that particular functions. Now in today's class, we are going to discuss the next topic called as NumPy. NumPy, where NumPy is one of the module or library. So it is also having a group of functions. In the once we import this NumPy, we are importing the NumPy, import NumPy. Once we import the NumPy, in the backend, numpy.py file will be executed. So the same py file, whatever we have seen yesterday, like srk.py, similarly numpy.py file will be in the backend. So all the functions which are related to NumPy will be in the backend, right? Directly we are going to use the functions which are available within the NumPy. Okay, various functions are available within the NumPy. Now, sir, why we have to use the NumPy? That is the basic and first question. And why we are moving towards the NumPy or advanced libraries? So already we are having core Python or everything. Why we have to move towards this one? Means here, if you observe this one, a is equal to 1, 2, 3, 4, 5. So simple example. Let us start with a simple example. A is equal to 1, 2, 3, 4, 5. Now print A. Print A means it is going to print the 1, 2, 3, 4, 5. Okay. This is the list. List it is going to print. And if you ask type of A, what is the type of A? If you ask the type of A, it is going to say it is a list type. It is a list type. So now A is equal to 1, 2, 3, 4, 5, and type of A means it is a list data type. Fine. Up to here it is fine. Now the question is, okay. Now if you see this one, print M is 1, 2, 3, 4, 5, list of 1, 2, 3, 4, 5, and it is going to have the next one called as data type as list. Now let us take a list of values like this. L1. Okay, everyone take this example. 1, 2, 3, 4, 5. Okay, list 1 is equal to 1, 2, 3, 4, 5 or 1, 2, 3, 4. Sure, just 1, 2, 3, 4. Okay, L2 is equal to 5, 6, 7, 8. This is L2, this is L1, and this is L2. Now I required an output. This is my input. Okay, this is my input. My required output is 1 plus 5, that is 6, 2 plus 6, 8, 3 plus 7, 10, and 4 plus 8, 12. So whatever we are having, these two has to be added in this way. That is 1 plus 5, 6, 2 plus this one, 8, 10, 12. I want the output in this way. This is my required output. This is the input and this is the output, and I'm asking you to write the code. What is the code? For having these like this, what is the code? So if you take L1 plus L2, L1 plus L2 is extend. It is going to be as extend. So where 1, 2, 3, 4, 5, 6, 7, 8, you are going to get like this. My requirement is not this one. So my requirement is this one. For getting this one, what is the code I have to write? Write in your notes, please. This is the input and this is the output, and I require the code. Write in your notes, answer, and take 2 minutes of time. 2 or 3 minutes or 5 minutes, whatever it is, and tell me answer. Whoever gives the answer, whoever writes the answer in the notes, assume that you understand the Python. Whoever can't write the answer for this one, assume that you don't know the Python. And you have to revise from the starting, or you have to do the more practice. Right? So as one of the student is using L1 of 0 plus L2 of 0. Okay, as first index value. Second one, they are using with respect to L1 of 1 plus L2 of 1. So for example, you are writing like this in this way. Here 4 only are there, so you are writing 4. For example, in the list 1, 50 are there. In the list 2, 50 are there. Then in that case, in the first list we are having 50. In the second list we are having 50 values. Then so either we are going to use for loop or while loop. Some loop concept we have to use. So here I'm going to use for I in range of 1, 2, 3, 4. So I'm going to use 4. Or if you're not, for example, 50 they have given or 40 they have given. Whatever the number we don't know means just use the length of list automatically. Okay, length of list 1. Length of list 1. Okay. Now for I in range of length of list 1. So now what happens within this automatically it is going to consider the 4. Now I value is going to consider as 0, 1, 2, 3, 4. Now what I'm going to do is L1 of I plus L2 of I. Means first it is going to consider of 0 means L1 of 0 plus L2 of 0. That is nothing but 1 plus 5. It is going to add 1 plus 5, which is nothing but 6. This 6 has to be appended into a new list. So the new list I'm going to write as n. N is equal to empty list. I'm going to take n is equal to empty list. And for this n dot append, I'm going to do this value. So for this, I have to store this one. First, I have to store this one. So I'm going to store in a variable called as v. And I'm going to append the value of v. So now what happens? First is 0, L1 of 0 plus L2 of 0. That is 1 plus 5, which is nothing but 6. V is equal to 6. And this 6 will be appended into the empty list. Next, I is equal to 1. L1 of 1 is 2. L2 of 2, that is 2 plus 6, 8. This value is 8. And this value will be appended in the empty list. Like this, it is going to append. Once everything is completed, I'm going to write print n. And it is going to print the answer. This is the output. Right? So first I have started with the for in I in range of, and I have written in front of you only the code. So just after writing this one, I want to append this one. I want to append means I'm creating an empty list. Right? So this is the code. Now for this code, whatever the output is there, for this code, I have to write total 5 lines of code. Code 1, 2, 3, 4, 5. Total 5 lines of code. The same thing, the same answer we can get. Okay, instead of writing these 5 lines of code, and you are getting an output with respect to list is equal to 6, 7, 8, 6, 8, 10, and 12. 6, 8, 10, and 12. 6, 8, 10, and 12. This is the output. This is the input. This is the code, and this is the output. Now, the same thing you can get. Input I'm going to keep as is. L1 is equal to 1, 2, 3, 4. L2 is equal to 5, 6, 7, 8. As it is, I'm not going to change the code. The output I'm going to write as np.array. First, I'm going to convert this L1 to an array L1 plus np.array of L2. Okay, np.l1 np.array of L1 plus np.array of L2 gives the output directly with respect to 6, 8, 10, and 12. This is the just in one line of code you can complete, and you are going to get an output like this. Simple. Now, just in the what happened here, this is a core Python code, this is a NumPy code. Now what is the difference between these two? Miss here 5 lines of code, whatever you are writing, here it is just 1 line of code. Now that is the advantage of NumPys. So but in the NumPy, what happens in the NumPy miss NumPy will consider in the backend with empty list, for loop, and within that for loop append function. A combination of for loop plus list is called as NumPy. Every time it is going to work on the same basis. Every function in NumPy is same. Every function in NumPy is for loop plus list. If you understand for loop and list means NumPy is completed. Every value you are going to select and you are going to append into an empty list. Every time it is going to print the final output of this one. So every time this is the common thing. For loop is common, append function is common, empty list and print is common. In between the code will change. Inside this, these lines will change. Whether 1 line or 2 lines, this part only will changes, but this one will remains constant in the entire NumPy. NumPy is nothing but for loop plus list concept is equal to NumPy. Okay. Now here, if you observe this one, sir, here, for example, I'm having in the list 5 elements are there. In the list 2, 4 elements are there. Now, in this case, for example, it is considering like this, automatically list of range of 5. You have considered list of range of 5. 0, okay. 1, okay. 2, okay. 3, okay. 4, okay. For 5, whenever the list range length of 5 is 0, 1, 2, 3, 4. 4 you are having. L1 of 0, okay. L2 of 0. L1 of 1, L2 of 1. L1 of 2, L2 of 2. L1 of 3, L2 of 3, okay. L1 of 4. L1 of 4 means you are going to get output as 5. But whereas L2 of 4, what is the output? It is going to throw index error. So this function will work only if length of L1 is equal to length of L2. If both of them are equal only, this will work. Otherwise, it will not work. So we are going to write within the for loop the condition, if length of L1 is equal to length of L2 only, it has to execute in this way. If both of them are not equal, it will not execute. The same to same will be automatically in the NumPy. In the NumPy, if the number of elements are same, it is going to work. If the number of elements are different, it is going to throw an error that both are having different shapes. One is having 5 elements, one is having 4 elements only. It is going to throw an error, right? So just NumPy means with respect to the NumPy equal to, simply to say NumPy is equal to for loop plus list, where it is going to do some kind of mathematical operations in a easy way. NumPy is full form of NumPy is numerical Python. Num is numerical. Generally, we'll apply the numerical data. We'll not go with the text data. Generally, 99.9999% of the times, NumPy is majorly designed for the numerical data, for numerical Python. For doing the numerical operations, we are going to select the NumPy. For doing all the numerical operations in a faster way. Because in a core Python, but every NumPy, this array is there, right? What is meant by array? Means in the backend, for each and every element. Array means for each and every element. For each and every element or value is called as array. Simple to say, array means this one. Nothing else. Means for each and every element means applying the for loop. Just applying the for loop. For each and every element means nothing but for loop. So just it is going to take the for loop and it is going to work. Right? Now, so here, if you select this NumPy, numerical Python, NumPy is a numerical Python, which is used to work with arrays. So NumPy, if you want to work means whatever the list of values are there, every list has to be converted to array first. Every list has to be converted to array. After converting to array only, you can work on the NumPy. NumPy will work only on the arrays, not on the core Python. So every list has to be converted to an array. In Python, we are having the list to serve the purpose of arrays. Same to same concept in core Python. In normal Python, we are having the same purpose, a list are there. But they are in the slow. When compared to the list, NumPy is very fast. Very fast. Here it is going to take in second means it is going to take, NumPy will take, list will take in terms of any seconds, some value in seconds means NumPy will do in the milliseconds only. The same work will be done in the milliseconds. Because automatically it has been integrated, right? So NumPy is an incredible library to perform the mathematical and statistical operation due to its fast and memory efficient. It is 50 times faster than your Python normal lists, right? So here, what is meant by NumPy array? You'll understand now. Import NumPy as NP. NP means standard format. Instead of NP, if you are interested only N also, you can import. That is your choice. This is nothing but aliasing. Okay, aliasing. For example, Sivaram Krishna is there. Shortcut is SRK. I can keep SRK, I can keep myself as Siva, or I can keep myself as Shivaram. I can keep myself, right? So I'm introducing myself as SRK to others means others also will call me as SRK only. If I'm introducing myself as Shivaram, and everyone will call me as a Shivaram only, right? So now here I'm going to import the NumPy as NP. NP is the standard notation. Okay. So I'm importing the NP. I'm going to import as NP. Now A is equal to a list of 1, 2, 3, 4, 5. Just observe this code. A is equal to list of 1, 2, 3, 4, 5. NP dot array of A. Now what happens inside that? NP dot array of A. What is A? List of 1, 2, 3, 4, 5. In the it is going to fill the value of A. It will fill the value of A. Whatever the A is there, 1, 2, 3, 4, 5, it is going to fill that value. And now if I print NumPy dot A, NP dot underscore A, this variable, if I print the variable, it is going to print the output as 1, 2, 3, 4, 5. And the type of, if I ask the type, it is a NumPy array. Now, if you observe carefully, this one and this one, please, I'm bringing this cell to up. Now, please observe the difference between these two. A is equal to 1, 2, 3, 4, 5, print A, which is list of 1, 2, 3, 4, 5. Here you are printing NumPy underscore A, which is 1, 2, 3, 4, 5. Here the type is list type. Here the type is array type. Now, what is the difference between these two means? In this case also you are printing, in this case also you are printing. But what is the difference means? This is a list, this is a array. Now, what happened in the backend? Why it is showing us, why it is not showing the comma? Comma means list. It is not showing the comma because it is an array. Array syntax is like this. Now, in the backend, just it is applying for I in A. It is going to take an empty, and for I in A, this empty list L dot append of I and print I. This is the backend code. Okay. Just for each and every element, it is going to consider the each and every element. For I in A means first I is equal to 1. It is going to take I is equal to 1 and it is going to append here 1. I is equal to 2, append here 2. I is equal to 3, append here 3. Every time it is doing the same. Just every time remember NumPy is with respect to for loop plus list. Okay, in a easy way. Okay, so NumPy array, whatever the array is there, this is one of the function. np.array is one of the function is available within the numpy.py file. In the numpy.py file, def array, they have created one function. How this function was created means by considering the for loop with an empty one. The same core Python code was there, right? Earlier I have written the 2 lines of code. That 2 lines of code they have created inside the function. Now when you are calling this function, automatically it is doing the same. This function has to be called minimum with one argument. You can convert one argument, one list to an array. Okay, so sir, list means for example list we can do the append, list.append we can do, list.extend we can do, list.copy we can do, list.clear we can do, list.insert we can do. Like this we can do the list, means manipulation can be done, right? List is an mutable object. Now NumPy is also mutable object. Whatever you can do in the list, everything is possible in the NumPy. That too very fast. When whatever we can do in the list, we can do in the NumPy. That too very fastly means in real life whether we are going to use the list or NumPy, then that is simple. In the real life we are going to use directly NumPy on. We no need to go with the list also. Today we have started the NumPy, right? From today onwards we'll work every day. In your entire data science career, you are going to, without this NumPy word, you can't even start the one line of code in the Python also. Even one line also you can't start. In your entire data science career, in the next 10 years you are going to be in data science means 10 years you have to use NumPy word. So for you to use the NumPy word for 10 years means, next 10 years means we should not by heart this one. We have to understand. For understanding NumPy, list is mandatory. Sir, anyways, NumPy only we are going to use in real life. Then why you have explained us list, sir? Without the basics, how the advanced part you can understand? Okay, example is very simple example. I'll tell you. In the real life job you are going to get based on the your degree, either BTech degree or BSc degree or whatever it is, some degree, MBA degree, whatever it is. Based on the degree, you are going to get a job. Degree is important means why to study LKG, UKG? Directly 5 years baby, 5 years person is there, right? Directly keep directly in the degree college only. Because based on the degree only you'll get the job now. With LKG, none of them will give the job. With UKG, no job is there. With first class, no job is there. Then why to study? But without the fundamentals, if you study the advanced part, you'll not understand anything. If you come with the basic part, from the basics or from the fundamentals, the advanced part will be easy. Now, when compared to NumPy, Pandas is still more advanced. And where we can do the multiple things, then this some disadvantages are there in NumPy. That disadvantage is also covered in the Pandas. Pandas is the most powerful library in entire Python for data science, particularly for data science. Okay. So for understanding Pandas, NumPy is compulsory because Pandas was designed using the NumPy plus dictionary. NumPy plus dictionary. Whatever the syntax we have used in the dictionary, the same syntax we are going to use in the Pandas. NumPy plus dictionary. Now what is meant by NumPy? NumPy means for loop plus list plus dictionary is equal to Pandas. In the core Python, if you know these three, Pandas is dead easy. Just in a half an hour we can complete. This you have by hearted. This one also you have to by heart. Obviously we have to by heart. There is no other option for us. Right? Now, here the NumPy. I'm going to import the NumPy as NP. Any library you have imported, you can library name dot underscore version underscore gives you the which version you are working. Okay, sometimes what happens means others will work on one version and you are working on one version and both will not be the same. For example, let us take in the Python 3.6, we are having some facilities are there. In the 3.11, what you are using as of now, you have installed your Anaconda or Python recently, assume you have installed 3.11. But we have worked from the 2 version also. In the Python 2 also, we have worked after Python 2, Python 3. In the 3.2, we have seen the version changes. In the each version, some upgradation they have done. Okay. So now which version we are working, we should know. So for that, what we have to do is, whatever the library name is there, just you can take the library name, any library name, whatever the library name, dot underscore version underscore. Okay. In order to execute this line, if you want to execute this line means this library, whatever the library is there, this library first you have to import. After importing only it will work. Without importing it will not work. First you have to import. After importing it will work. For example, you have imported NumPy. Import NumPy. You have imported NumPy. Then NumPy dot underscore version underscore underscore. For example, you have imported NumPy as NP. Now, if you ask NumPy dot underscore underscore version, if you ask like this, it is going to throw an error because what is NumPy? Don't know, because NumPy was NP, right? Okay, NP. So NP only we have to use here. Whatever you have imported, in what way you have imported, the same thing you have to use here. And in the further also, we should not use NumPy dot array. Though it is the library name also NumPy also, we cannot use NumPy dot array. For example, let us take like this. Instead of here, I'm writing NumPy. Okay, it is going to throw an error. What is NumPy? It doesn't understand what is NumPy because NumPy was imported as NP. It knows only NP. Okay, simple, right? So this is the version which I'm working 1.21.5. Okay, as per the latest version. In your system also, you are having the latest version. This one, this is the latest version, right? Now in the NumPy, we are having different types of arrays, out of which 0-dimensional array, 1-dimensional array, 2-dimensional array, 3-dimensional array, 4-dimensional array, like this, n-dimensional array. From 0 to infinite dimensions, we can work on the NumPy. Okay, NumPy arrays are n-dimensional. N-dimensional. They are not with respect to 1 dimension or with respect to 2 dimension. It is n-dimensional. Many of you don't know what is this dimensional. Okay, 1 dimensional, 2 dimensional, 3 dimensional, 4 dimensional. What is this dimensional? Some of the students may not know. So for them, I'm explaining in a simple way. For example, if you are having a straight line, a simple straight line, then it is called as a 1-dimensional. Okay. Now the same thing, if you are having in front of you, you are watching a screen. Online students, they are watching the screen, and offline students, they are watching the board. So whatever the screen you are seeing, this screen with respect to it is a 2-dimensional. The screen is having with respect to some breadth, some height, some width is available, some length is available. Whatever the screen you are observing, right? Now, what is meant by 3-dimensional? 3-dimensional means, for example, this room, whatever the room you are staying, in front of you, one wall is there. The wall, whatever you are seeing, the straight wall is 2-dimensional. But the side one, left side, you are having some wall, right? That one is the 3rd dimension. The side, we are having the 3rd one. So these are the 2. This is the first one. This is the second one. And along with the 3rd one, this is the 3rd one. 3 dimensions. So this classroom was designed with respect to some width, some height, along with that, some breadth. 3 dimensions are there. So whatever you are saying straightly in front of you, whatever the wall is there, that is having with respect to this dimension, X dimension, Y dimension. But what is the length? Classroom length is there, right? That is the 3rd dimension, right? So simple example for your 3rd dimension is cube. Okay, cube. Where in the cube you can see with respect to Rubik's cube. I'm saying about the Rubik's cube. So where in the Rubik's cube you are having total 6 colors are there. Out of which one of the color you are going to see in the front. Front side you can see with 1 color. Side you can see 1 color. This side you can see 1 color. On the top 1 color. Bottom 1 color. Back side 1 color. Each one is called as face. Each face is a 2-dimensional. Like this, you are having 6 2-dimensional faces. So multiple 2-dimensional is equal to 3D. Multiple 1-dimensional is equal to 2D. Right? So now, sir, example of 4D. Okay, 1D okay, 2D okay, 3D okay. Now 4D. Now 4D is, anyone has seen any 4D element? Anyone? 4D. Anyone can give me the example for 4D? 4D element, none of them we can see with our eyes. We can't see with our eyes. Our human eyes are designed up to see only 3-dimensional. 4th dimension we can't see. If you can see the 4th dimension means you have to visit the Vasanai cave, right? So we can see only with respect to 3-dimensional. The maximum we can see is 3-dimensional, right? So then 4D means how we can see that one, 4D. At a time you can see only 3D and you have to rotate that one. The 3-dimensional part we have to rotate and then only we can observe the 4th one. After rotating only we can observe that one. At a time we can see only with our eyes, 3 dimensions only. 4th dimension with our eyes we can't see. So in the interview they'll ask a simple question. One time I have asked one question to one of the person. What example what is NumPy? I asked one NumPy means, he told that sir it is an arrays, n-dimension arrays, we can work on the n dimensions. Okay, fine. N dimensions means how many dimensions? Numbers are no problem. Okay, can you explain one example for 3D means? He has explained 3D example. I asked 4D. He has told me some example. I don't remember also. Some example he has told me. Have you seen that one? Yes, sir, I have seen. Then I was shocked. Can you show me that one, miss? He has shown, but it is a 3-dimensional one. With an eye, we can see only a 3-dimensional images. We can't see the 4D. Okay. Now, coming to the arrays. In the arrays, we are having 0D, 1D, 2D, 3D, 4D, 5D like this. Okay. Now, 0D. 0D means if you are having only one element, one single element like int, float, complex number, or boolean, these basic things comes under 0D. Single element. Only one element is considered as 0D. Right? Where np.array of one value, I'm writing 42, only 42. And if you observe this one, array, whatever the array you are having, and type of the array is NumPy array, because you have converted this 42. It is not the int object, it is a array object. Sir, a is equal to 42. Print a. If you print a also will give the 42 only. A is equal to 42 and print a. Here also it is 42. Here also it is 42. Both are same. This one outputs are same. Wise you are observing this output and this output, both are looking as same, but both are not same. Here the a, if you ask the type of a, the type of a is int type. Whereas the type of ARR means the type of ARR is with respect to array type. That is the difference between these two. Right? Now, instead of that, if you write directly print a, instead of print a, if you write normal a, directly instead of this normal a, if you have written, instead of writing the print word, if you're not using the print word, directly you're asking like this. Now here also you're printing the same thing. Now you can see the output of array of 42, not as 42, array of 42. So what is the difference between this one and this one? Means print function will not show the array. Print will not show the array. Directly inside the value only it will print. But whereas if you're asking the variable will print along with the data type also. For example, here if you ask a is equal to srk, something you have written like srk. If you ask print a, what is print a? It is going to print the srk only, just srk, 3 letters will be displayed. But if you ask only a, without using the print only a, if you ask means string of srk will be visible. Along with the data type also it will be visible. Here also along with the data type it is visible. If you ask only this one. If you ask a print means the data type will not be visible. Only in terms of value only it will be visible. Right? Now, a is equal to np.array of list of values. Here now I'm not going to consider one value. I'm considering a list of values. The list of values where if you ask print a means 0, 1, 2, 3. It's the same thing if you ask only a. Instead of print, you are asking only a. Then it is going to print as including the data type array of. It is going to print array of 0, 1, 2, 3. Okay. It is not normal 1, 2, 3, 1, 2, 3, 4. It is an array of 0, 1, 2, 3. Right? Now here, how many dimensions we are having? A dot dimensions, n dimensions. A dot n dimensions means it is a one-dimensional array, because this is a one-dimensional array where it is having the multiple values. A dot shape. This is most important. Shape. Shape gives you the number of elements present in the A. So the shape, how it is going to give the shape means the shape will return always. The shape will return always the tuple as the output. In the notes you have to write compulsory shape. It always returns the output as a tuple of elements. It returns a tuple. The output will be a tuple. It returns a tuple. The shape will be always a tuple. Most important. Shape will be always a tuple. So now here the shape, whatever the shape is there, a is equal to 0, 1, 2, 3. And if you ask a dot shape, it is going to print 4 comma tuple of 4 and next value it is not printing. So that is the syntax for one dimensional. Syntax for one dimensional. For example, if it is printing the second number, one more number it is printing, it is the 2 dimensional. If one more number is printing 3 dimensional. If one more number is printing 4 dimension. Here how many numbers are there? That is the number of numbers are there. That is the shape. So for one dimensional NumPy array, the shape syntax. What is the syntax is? The syntax is number of values in that array, comma is the syntax. Syntax is number of values, comma. The second value should not be printed. That is the syntax for the one-dimensional array. How many values you are having here? Total 4 values are there. So 4 comma. It is going to print 4 comma. For example, let us take here 5th value, 6th value, 7th value. Some. Okay. Total how many values are there? 1, 2, 3, 4, 5, 6, 7. So now it is a one-dimensional array or two-dimensional array? Dimensions is one only. Dimensions is not going to change only because it is having only one list of values. So it is a one dimensional array, but the shape is number of values, comma, simple. Number of values are 7 values are there. So 7 comma. It is displaying 7 comma. Is that clear? That is the syntax for one dimension. Now coming to the 2 dimension. Okay. Now coming to the next one is called as 2 dimension. For 2 dimension, what we are going to do is nested list. Instead of going with a list of 1, 2, 3, sorry, for example, like this. Let us take like this. Okay, L is equal to list of 1, 2, 3. This is a one dimension. The same thing, if you consider as a nested list, 1, 2, 3, 4, 5, 6. A list is consisting of this main list. Now tell me in the list 1 and list 2. In the list 1, what is how many elements are there? Number of items in list 1 is equal to 3. Now number of items in list 2, how many? Only 2 items are there. Okay, now if you convert this np.array, if you take the np.array of L2, the nested list, if you are converting, now it is considered as a 2-dimensional array, where the first dimension is 1, 2, 3, second dimension is 4, 5, 6. This is your second dimension. 2 dimensions you are going to get. Okay, where number of rows, this is each list is considered as one row. Each list, how many rows are there? Each list will be considered as one row. Nested list we have to consider for the 2-dimensional arrays. Now if you ask, for example, I'm storing this one in the ARR2. Now ARR2.ndim, if I ask means it is a 2-dimension. If ARR.2.shape, if I ask the shape, it is going to print number of rows, comma, number of columns. That is, number of rows are 2 rows and 3 columns. This is the 2-dimensional. 2-dimensional array means simply to say matrix. Everyone knows matrices, right? The same matrix is a 2-dimensional. Simple. Okay. So 2, 3. Whenever the next number here in the shape 2 numbers are visible, it is automatically indicates that it is a 2-dimensional array. Is that clear? Now, shape. Sir, can you please explain the shape again? Yes. So let us take one more example. A is equal to, or A2. A2 is equal to, I'm going to consider as a list. List of first one, 1, 2, 2, 3. Next one is 3, or 4, 5, 6. This is a nested list. Everyone is okay with the nested list? There is no question in the nested list, right? Now, what I'm going to do is ARR2 is the variable name. Array 2 is the variable name. I'm going to convert this one, np.array of A2. Just I'm going to consider A2. I'm converting this one as array. Now, when I have converted this one as an array and I'm printing this, print ARR2. I'm printing ARR2. Now, if you observe this one, it is going to show like this. Now, instead of this one, if you are having only one list, the output will be with one bracket. It will open only with one bracket where 1, 2, 3 is. So can you see here? It is having only one bracket. If you ask a print of A. So I'm keeping this one down so that you can compare both of them side by side. Right? So if you can observe this one, what is the first one? A of, let us take one more time. A is equal to 1, 2, 3, or otherwise let me write like this. A1 is equal to list of 1, 2, 3. A of 1, 2, 3. Now this is list ARR1. I'm writing ARR1. Array 1 is equal to, I'm converting this one. Now if you print this one, ARR1. If you print ARR1, now can you see this output with a single bracket? The bracket is 1 only because this is a normal list. For 2-dimensional arrays, we have to use the nested list, not with a normal list. And the output also, it will be visible with double brackets will be open. This bracket indicates this is 1 dimension, this is 1 dimension, and overall it is a 2 dimension. Now it is clear. So A1, A2. Just I'm converting them. Done. Because just see, this I want in a first row, this I want in a second row. That's it. For example, I'm having like this. Generally in a core Python, what we have to do, we have to assign two different variables. Here or 2 different variables, or we have to take in a nested list. This is the only option, right? Either you have to take in a nested list or you have to take with two variables. This is the first list you have to store in the first variable. The second list you have to store in the second variable. Or second option we are having is nested list is the second option. Now this nested list we are going to convert as a array. Now here if you ask ARR1, ARR1 dot enddim. What is ARR dot enddim? Only one bracket is opening, so it is a one dimension. Now here the same thing I'm asking here also same ARR2 dot enddim. It is a two dimension because here two brackets are open because it is a nested list where multiple rows are available, not with a single row. Multiple rows are available, right? Now, sir, still more. Let us make clarity. So let me delete this one also. So 1, 2, 3, 1, 2, 3 only. Here, instead of going with a one normal bracket, this is a list. This is a nested list. Now here, if you observe this one and this one, if you convert, where one row only is available, one row. Just now it is simple, still more simple. What is the difference between these two? In this cell and in this cell, what is the difference you have observed? One more extra list of bracket you have observed. Is there any difference else? Asterisk only, right? Same example, one more bracket. That one more bracket nested list indicates the two dimensional. Is that clear now? Now, here if you ask ARR1 dot shape for one dimension, because first it is going to take the ARR1. What is ARR1 means? 1, 2, 3. First it will collect that value, whatever the value. For this, it is going to apply the dot shape. Since it is having only one bracket means one dimensional. For one dimensional, what is the syntax they have created is number of values, comma. This is the syntax. Now, same question I'm asking for ARR2 dot shape. ARR2 dot shape. Now, once I ask this one, now first ARR2, what is there in the ARR2? Double square brackets of 1, 2, 3 dot shape. Now, first it is going to observe how many brackets are there? Two brackets are there. Two brackets means two dimensional. For two dimensional, what is the shape? Means the shape was given with two values, out of which first value is number of rows. How many rows are there? One row. Next, number of columns. How many columns are there? 3 columns. This is the syntax for the two dimensional. Clear now? Is that clear? So just that is the difference between one dimensional and two dimensional. Shape is clear now. In the backend, shape, def shape, whenever you are asking the shape function, in the backend, first it is going to check if brackets are equal to one bracket. For that, the shape they have created according to that. For two brackets, the shape according to that they have created. If and else. Okay, based on the number of brackets. Shape means it is number of rows and number of columns. It tells us the number of rows and number of columns in the two dimensional. Now for three dimensional, how it is going to select means Rubik's cube. Everyone knows Rubik's cube, right? Rubik's cube is the simple example because everyone knows that one. Now in the Rubik's cube, we are having the front one color is there, where the color 3 by 3 Rubik's. Let us assume a 3 by 3 Rubik's, out of which 3 by 3 means the shape is 3 rows, 3 columns, and how many like this are there? 6 are there. So the shape of that one is 3 by 3 like that, 6 are there. The last number indicates that how many two dimensionals are there. Is that clear? So 6 are there. So Rubik's cube shape, if you give the Rubik's cube as the NumPy array, it is going to show you as 3, 3, 6. So whenever we are working on the one, first let us complete the one dimensional and how to work on the one dimensional. Let us focus only on the one dimensional. Later we'll focus on two dimensional. Later we'll focus on the three dimensional. In the real life, where we are going to use three dimensional means in the images. When we are going to work on the images, that we are going to work on the three dimensional. Where we are going to work on the two dimensional means any structured data like number of rows and columns. We are having the Excel sheet or CSV files, all these files, any structured data where tabular column is there, where tabular data, two dimensional means wherever you are having the tabular data. In that case, we are going to use the two dimensional arrays. When we are going to work on the list, wherever the application of list is there, instead of list, we are going with the one dimensional array. Is that clear? For two dimensional, for one dimensional list, than list array is the best option. For two dimensional, than NumPy, pandas is the best option. You will understand. I will explain one by one. Don't need to worry. Just you have to focus as of now. Just understand what is one dimensional and how the one dimensional shape will look. That is important. That's if you understand up to this, it is more than sufficient. Right? Now, what are the various functions are there for creating one dimensional array? These functions are used for creating, like for example, list of range of 0 to 10. What is the meaning of this? 0 to 9, you are going to get as a list. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. This is a list, right? Where 0 to here, you are going to generate a list of numbers. The same way, here also I'm going to generate array of numbers. Array of numbers. There the list of numbers. Here it is array of numbers. Where the function is np.arrange. Arrange is the function. So just it is going to open the numpy.py file. Within that, there is a def function. Def arrange. Where this arrange was taken with 3 arguments. Out of which first argument A, B, C. Out of which A is, if you don't write anything, by default it will consider 0. 0, B, C if you don't write anything, plus 1. So 2 are default arguments, 1 is compulsory argument. So that is the range of 10. 10 means now 10 is considered as end value, not as the starting value, because the first value default argument. If you don't write anything also, it will automatically consider. Right? The function was created with 2 default arguments and 1 is compulsory argument. For the other 2, if you don't write means automatically it will consider. This one is only the compulsory one, which you have to write. These 2 are not mandatory. If you write miss, then automatically it will consider this one only. Right? So now here I'm writing 10 to 101 with an increment of 10. So what is the first value? 10, 20, 30, 40, 50, 60, 70 with an increment of 10, right? 80, 90, 100. 101 should not be included, so 100 will be also included. So from here to here, instead of list, I want as an array. Now array, how it is going to print array? 10, 20, 30, 40, 50, 60, 70, 80. The array will be printed in this way. List will be printed in this way. Array will be printed in this way. If you ask a list of range of 10, 101, 10, if you give the out this one, this is the code. This is the list code. The same thing here we are having arrange, not range. Arrange. A means array. A indicates array. Range means normal range function only. Everyone knows range function, right? The same range function. So where starting, ending value, and the step. So now it is going to print the values like this. If you want, you can open the shift tab also, and you can see here. So it is arrange function takes the 3 values, out of which start, stop, and step. Start value, if you don't write anything, by default it is going to take the 0. And next step, whatever the step is there, step automatically takes the value of plus 1. Right? So if you want, you can read this one. Down you can read. See, start value, it should be an integer. And start of the interval. The interval includes this value. Starting value is included. The default to start value is 0. They have written clearly in the help file. You can read here directly. If you're not, whenever you are working on a new function, just we are going to open the help file and we'll read the entire help file. What is the use of this particular function and what are the parameters? Out of those parameters, which are default arguments, which are non-default arguments, we'll understand each and everything. And according to that, we are going to work. Is that clear? Now, line space. Next example is line space. One is arrange. First function we have discussed is arrange function. Now, second function we are going to discuss is line space. In the NumPy, the second function is line space. Now, line space means it is going to create a one-dimensional array with the starting value and ending value. So the syntax is starting value and ending value with total number of samples between them. Okay. So what is the use of line space means? It is going to return the evenly spaced numbers over the given interval. For example, I'm going to consider like this. Let us take like this. 0 to, I'm going to take 0 to 5. In between 0 to 5, total number of samples. How many total number of samples you want? Total number of samples, I want only 2 samples. Means the first value from 0 to 5. 0, 5. That's it. Only 2. Including these two also. These two also included. This is the 2 samples. So it is going to print only 0 and 5. For example, I'm asking 3 samples. 3 samples means 3 values should be taken. The 2 equal space. Equal space means 2.5. 0 to 2.5. 2.5 to 5. Equal space, right? Total 3 values. First value, second value, third value. So if you give 3, it is going to print 0, 2.5, 5. Sir, I want 4 values. Assume that I want 4 values. From 0 to 5, I want 4 values which are equally spaced, including 4 and 5. Now what do you have to consider? 4 values means 1.25, 2.5, 3.75. Now how many values you are going to get? 5 values you are going to get. This is 5 values. No, I don't want 5 values. I want only 4 values. Then what I have to take? 5 values means 1.667, 3.333, and 5. Equally spaced. From here to here the distance, and from here to here the distance, and from here to here the distance, everything is same. So total 4 values you are going to get like this. Sir, I want 5 values, including 0 and 5. 0 and 5 also will be included. I want 5 values. Then 5 values means how? 5 values means 1.25, 2.5, 3.75. Sir, how to select these values, sir? What is there any formula for that? Yes. End minus start divided by number of samples minus 1. 5 minus starting value is 0. 5 minus 0 divided by number of samples you require 5, right? 5 minus 1, which is 4. So equal point is 1.25. So you are going to get 1.25. Is that clear now? This is the formula. If you are interested in formula, this is the formula. Concept is equal number of spacing values. It is going to print the equal space values from 0 to 5, where these both are included. These both are included. So here, if you observe, this function was created with start and stop. Start and stop means starting value and stop means ending value. Where the number of samples by default 50 it is going to consider. If you don't write the numbers means 50 it will consider. By default it is going to consider the 50 samples, right? So here, if you consider here, returns the evenly spaced numbers over the given interval. So where the starting value, ending value, including the number of samples. How many total number of samples you want, right? This class only. Data science. First day. You are coming for demo, huh? Not here. Today new batch is started in other campus. Just ask them. Right? Next one is np dot. First we have seen np dot array, np dot arrange, np dot line space. Now next one is np dot zeros. Next function is zeros. Okay, np dot zeros. So it is going to generate the zeros, completely a list of zeros, only zeros. Generate an array of zeros. So just here you have to give the input as the shape, whatever the shape. So I'm going to give the shape np dot zeros and input should be the shape. Here the shape is, what is the shape is 20 comma. What is meant by 20 comma? One dimensional array I want with respect to 20 values. It is going to generate 20 zeros with a one dimensional array. It is going to generate 20 values, 20 zeros. Just it is going to give the 20 zeros. For example, I have given 2 comma 3. What is meant by 2 comma 3? Shape of 2 comma 3. 2 rows, 3 columns. It is going to give 2 rows and 3 columns. 3 by 3. 3 rows, 3 columns. It is going to give the 3 rows and 3 columns. Right? So what is the use of this np dot zeros? Means in the matrices, if you are working on the matrices, at the time we are going to use these zeros, null matrix. Do you remember null matrix? Null matrix means which is having completely of zeros. So to create the null matrix, we are going to use this function called as np dot zeros. Okay. Is that clear? Next, np dot ones. np dot ones of shape. I'm going to give the shape as shape is equal to 2 comma only. What is meant by 2 comma? 2, a one dimensional array with 2 values which are filled with ones. If you are writing 2 by 2, 2 rows, 2 columns, which is filling with ones. What is the use of ones means? Unity matrix is there. Null matrix, unity matrix. So these functions are created for working on the matrices. We are going to work on the matrices in the further class. Okay, there is one algorithm which is called as PCA. This PCA algorithm will work on the matrix concept. At the time we require the matrices. For that matrices, this is the basics. This PCA we are going to discuss after 1.5 months or 2 months. Maybe 2 months later we are going to discuss. At the time you have to remember this np dot ones or np dot zeros. I'm not going to revise once again. This PCA algorithm will work on the concept called as matrix. At the time I'm going to explain the matrices concept. So total in the max we require 3 things. One is linear algebra. Linear algebra means not entire linear algebra. Within the linear algebra I require only the matrix. That too basic part. I don't want inverse. I don't want with respect to high level how to calculate the rank. These things I don't require. I require only the basic matrices. Right? The second one is required is differentiation. Differentiation means again not high level, only the basic level. D by dx of x square, d by dx of modulus of x. If you understand these two, completed. Differentiation is completed. And these two I'm not going to use none of the formulas. Only these 2 formulas I'm going to use. Third one in the max we are going to use is probability. Again the basic probability only. Only the basic probability, not with respect to IIT probability, right? Don't assume that permutations, combinations, probability theorems, and number of balls in the bucket and green balls, blue balls, nothing is required. Only the basic things are required. Just a basic, very basic level is required. 3 of them we required, but everything in the basic only. That is in less than your 10th class. Whatever you have completed till your 10th class, it is sufficient, not more than that, right? But at the time, we are going to use this one. np.1s, np.0s, np.line space, all these things we are going to use at the time. Next, we are having the random.randint. So np.random.randint. Yesterday, we have seen in the random module. Random.randint. In the yesterday's class only, we have completed this one. And here, in the yesterday's class, we have given 1 to 41. 1 to 41 means it is going to select randomly one integer from the given of 1 to 41. It is going to select randomly. For example, if you want 5 numbers, then what we have to do? For loop. For I in range of 5. This we have to write. The same code in NumPy we can write as np.random.randint 1 to 41 with 5. The next value indicates the number of samples. Number of samples is nothing but for loop. In the backend, it is applying for loop. I told you, right, already, list plus for loop. So it is automatically applied the for loop. So just from 1 to 41, it is going to select 5 values randomly. Random integers, it is going to select 5 values. Randomly, it is going to select. Is that clear? Done? So once again, the student is asking ones. Ones means it is going to generate an array of ones. That's it. Simple to say, it is going to generate an array of ones. If you write 3 comma means 3 ones you will have. 20 means 20 ones you will have. Here you have seen with respect to zeros, right? So here we have taken with 20 comma. This is zeros and this is ones. Here it is going to take all the zeros. Here it is going to take all the ones. Values will be filled with ones. All the values will be filled with 1. Is that clear? Sir, we are having zeros where all of them are filled with zeros. 0, 0, 0. Okay, something like this. Now ones. Ones means 1, 1, 1. Let us take like this a simple example. 3 comma. 3 comma means 3 values. It is going to take 3 values. Okay, sir, 3 values of zeros, 3 values of ones. Zeros is there, ones is there. Next, for 2s means 2s are, 3s means 3s, 4s means 4s. No, we are not having these all the things. Only ones and zeros only we are having. Sir, why for ones and zeros only they have created? In the matrix we are having with null matrix, identity matrix. 2 matrix is there. In the matrix, 2 matrix is there. 3 matrix is there. No, right? We are having either null matrix is available or unity matrix is available. Identity matrix is available. Identity matrix means where we are having 1, 0, 0, 1. Diagonal elements of 1. These are the things that are available. So which are universal, common for everyone that they have created the functions. Sir, but I want with respect to the 2s. I want 2s. Means an array of 2, 2, 2. Now what I have to do? This I want. Just very simple. np.ones of 3 comma. First you have to take this one. So now it is going to take 1, 1, 1. For that you have to add 1. Now automatically for loop will be considered. For loop means for each and every element it is going to add the 1. So first value it is adding 1. Second value 1. Third value 1. So automatically you are going to get 2, 2, 2 like this. This is the output. If you add plus 1, simple you can get. If you add plus 14, 15, 15, 15, 16, 16, 16. Like this you can get as per your choice. Is that clear? So just you have very simple. For example, you are having a list. Let us take a list. List of 1, 1, 1. This is the input code. I want the output. Output I want as 2, 2, 2. Can you tell me the code? What is the code I have to write? This is my required output. Without using NumPy. Without using NumPy, what is the code? For I in L for L plus I plus 1. This I plus 1. First I in L means first it is going to take 1. 1 plus 1, which is 2. And this value you are going to store somewhere. And you are going to take some kind of new list. And this new list you are going to append this value. And the print n. This is the core Python code. The same thing here. I already told you, right? Append, empty list, print, and for loop is called as NumPy. Just only this one you have to take. Plus 1. np.array plus 1. This is the code you have to write. That's it. Already this one. NumPy includes the NumPy, right? Is that clear? Now, how to access the elements? Array was created, array of values are created. Now, how to access the values? Means indexing. How to do the indexing? Same to same. In the list, what we have done, the same. Slicing, same. I told you during the slicing and indexing, I have told you that in the strings, we are going to use the same. In the list, we are going to use the same. Tuples, we are going to use the same. And in the NumPy, in the pandas also, the indexing and slicing will remain constant. There is no difference. Okay. So A is equal to np.arrange of 10, 101, 10. What is the meaning of this? It is going to create an array of 10, 20, 30, 40, 50, like this. So let us take 51 only. I can't write that many numbers. I will stop here on. So 50. Okay, every time erasing and every time writing this, it is difficult. Okay, let us go with a simple example, 10, 20, 30, 40, 50. Okay, this is an array. Now within this, you are going to use the indexing. A of 2. What is there in the A of 2? 0, 1, 2, 3, 4. Minus 1, minus 2, minus 3, minus 4, minus 5. What is in the A of 2? It is going to print that one. A of minus 1. What is in the minus 1? Minus 50. If it is a list means, if assume that it is a lister. For lister, how it is going to work? For NumPy also it is working the same. No difference. In the list, if you are asking, for example, if you take a list of 10, 20, 30, 40, 50, if you're a lister, inside the list, if you ask a list of 5, what happens? 0, 1, 2, 3, 4 is there. List of 5, what happens? Index is out of range. Index error. You are going to get an index error. Here also the same. If you ask 5, same error. As it is, no difference. In the list, how it is going to work? Here also it is working the same. Okay. In the list, if you ask A of 2, 30 will be printed. Here also 30 only will be printed. Here, the 30 output, whatever you are going to get is an int object. Here, the 30, whatever you are going to get, it is an array object. That is the only difference. We are working on the arrays. Right? Now, you are accessing the multiple values based on the indexing. Now, A of 1 to 5, that is already A is equal to array of 10, 20, 30, 40. Don't keep the comma. If you keep the comma, means it is listed. If you don't keep the comma, it is an array. That is the difference, right? Now, A of 1 to 5 with an increment of 2 means what is the meaning of this? 1, 3, and 5. 5 should not be included. So 1 and 3. What is in the index position of 1 and 3? 20 and 40. So it is going to print the array of 20 and 40. Array of 20 and 40. Is that clear? Array of 20 and 40. Now, there is an interesting question. List is equal to a normal list. Once again, 10, 20, 30, 40, 50, 60, 70. Assume it is a normal list. It is a normal list. Okay, I have kept commas also. List. Now, inside this list, this is the input. Code is input. I require the output 10, 20, 50, 60. I want this one. There is no pattern is available. If the slicing, for the slicing step function is pattern is available, means slicing is okay. If there is no pattern, first this one, again you are asking this one, you are leaving this one, again you are asking this one. For example, I'm not asking this one, I'm asking with respect to 70, assume 70, this one. Now, from the list slicing, through slicing, can we get this one? No. Then what is the other option for getting that one? I want, this is the output. For this, what is the code, guys? This is the input and this is the output. What is the code? Giving the input and giving the output and asking the code is the Python developer role. For Python developer, this is the work. Input is fixed, output is also fixed. We have to write the code. The Python developers has to design the code for the given output. That is the Python developer work. A programmer or a developer work is that one. Output is fixed. In the interview also, they will ask like this one. Interview questions for the Python developer also, they will give one input line and output. And for this, what is the code? This is the interview questions for the Python developers. For data scientists, next level. This is a basic level questions. For data scientists, very strong level, very high level questions will be there. Okay. If you're not able to answer the basic level questions, miss, understand where you are staying and which stage you are there, and please revise and please practice. Okay. Slowly we are going to increase the level. To me, as of now, we have completed only LKG and UKG. In data science, we have completed only this one. And as of now, I'm in the first class. We are in the very basic stage only. We have to complete the BTech, and if possible, even MTech also we have to complete. If time permits, MTech also will complete. Minimum BTech we are going to do. From the basic level to BTech level, we are going to complete. In the basic only, you are getting struck off, miss. Okay, practice every day. If you miss one day also, next day the movie will be as a Kannada movie only. I told you at the starting and you have laughed at the time. Slowly it is going to be a Korean movie if you don't practice this. Okay, please practice every day. Okay, now coming to this. This is the output. Now for this output, what is the code we require? In the Python, normal core Python. Tell me for a normal core Python, what is the code? You are going to apply the for loop and you are going to check the condition, whichever the index numbers you want, that index numbers, if it is satisfying in that index numbers, that values you are going to select it. Same to same. But in the NumPy, it is very simple. For same example, whatever the example I have written here, I'm writing the same example here. L is equal to list of 10, 20, 30, 40, 50, 60, 70. Okay, this is the L. Now, first, what I'm going to do is this I'm going to convert as an array. A is equal to np dot array of L. First, I will convert to array. After converting to array, now A of index I'm doing one value I'm selecting means one bracket only. If I want multiple index values means list of values. List of values. Inner bracket indicates that list of values. So list of values. What are the list of index numbers I want means first index number 0, second index number 1. 0, 1, 2, 3, 4, 5, 6. Third index I want is 4. And next index number I want is 6. These are the list of index numbers which I want. So it is going to print the output as 10, 20, 50, 70. Just this is the input and this is the output. For that you require only 2 lines of code. The 2 lines of code is one is converting to array, second one is accessing the index elements. So you can access the multiple index elements to slicing through this one also. 2 options we are having. This option is not available in the core Python. This option is available only in the NumPy. Okay. Either you using this one also you can access multiple elements. Using this one also you can access. Just you have to take array. Array of single value means directly write the single value. If it is multiple values means array of list of values. Multiple means list of values. Single means single value. Directly write the single value. One value. So I have shown you list of values example. This is single value example. Okay, is that clear? Done. Next, how to access the elements based on the condition. Again normal list. This is the last example. And why I'm comparing every time with the list, because today I will compare, but in the tomorrow's class I will not compare, because once we cross the stage means directly we'll move on to the next level. Since first time we are learning the NumPy, if you learn the list means it will be easy for you. That is the reason every time I'm comparing with the list. Okay, so here 10, 20, 4, 5, 8, 11, 7, 3, 9, 16. Something you are having like this list. Now, this is the input. I required output is only the even numbers. That is 10, 20, 4, 8, 16. I want this one. This is the output. For this, what is the code I require? Other than array. Don't apply array. Without array, core Python code. I want core Python. Just for I in L, you are going to check whether this I is divisible by 2. If it is divisible by 2, this particular value should be appended to a empty list. N dot append of I and print N. Done. This is the core Python code. Empty list, for loop, append, print. 4 options. Now I am going to convert this one to np.array of L. Okay. np.array of L, that is A is equal to, and inside the A, directly this part, whatever it is there, this part I'm going to write here directly with respect to L divided by 2 is equal to 0. Directly you'll get the output. Okay, let us see that example. So here, whatever the example I have written, the same example I'm writing here. L is equal to 10, 20, 4, 5, 8, 11, 7, 9, 16. Okay, first I'm going to, this is the input code. First I'm going to convert it as an array. A is equal to np dot array of L. First I'm converting to array. After converting this one to array, now what I'm going to write, this condition. This condition is nothing but A. A is divisible by 2 is equal to 0. Now here equal to 0 means, now what is this operator? Comparison operator. Comparison operator, what is the output? true or false. So it is going to give me either true or false. See, first element is true. Yes, it is divisible by 2. Second element is true. Third element is true. But fourth element is false. It is going to give the true or false because it is a comparison operator. The output of the comparison operator is either true or false. So no, I don't want the true or false. I want the numbers. Numbers means A of like this. If you write now, wherever this condition is satisfied for the given number, it is going to select that numbers and it is going to print. So this is the output 10, 24, 8, 16. Can you see? If you don't write A of, it is just giving the either true or false as the output because the comparison operator output is either true or false. A is an array. For each and every value, it is applying the true or false comparison operator. For each and every value, it is applying the comparison operator. So it is going to give for each and every value true or false. But I don't want the true or false. I want the list of values. So A of E, this one. That is the syntax. Array, in the bracket, we have to write the condition. By writing the condition and extracting the elements is called as fancy indexing or mask indexing. By writing the condition and extracting the values is called as fancy indexing or mask indexing. Most important. Most important, right? The same thing in the SQL also. The SQL, most of the SQL in the SQL, we have to extract the values. In the here we have seen here extracting the values, right? What is the heading? What is the heading for this? Accessing the elements or extracting the values. Whatever the values you require, you are extracting the values. Accessing the elements or extracting the values, right? So you are extracting the values. The same to same, we are going to extract from the database. In the database, let us assume the same numbers are there. From the database, you want to get this one. In the SQL, we are going to write select star from L, wherever the condition L is divisible by 2 is equal to 0. This is SQL command. Concept is same. Where is nothing but if. In Python, it is called as if. In SQL, it is called as where. Right? So just we can access the elements in an easy way just by based on the condition. So this one is called as mask indexing or fancy indexing. Right? So in tomorrow's class, we are going to discuss the next concept, how to modify the elements, and along with that, 2-dimensional array, how to work on the 2-dimensional arrays that we are going to discuss in the tomorrow's class.